Once again, sort of in the spirit of being an open, collaborative place where we want to be able to invite lots of people in, we love hosting symposia and workshops and just being, a really active participant in the overall research community, right? So, we're standing right now in the reception area of the building, right? And we're on
first of all, who are you? Because this will probably run first because we're at the entryway of the Microsoft Research Building.
Sure. I'm Kevin Schofield. I'm general manager in Microsoft Research. I'm sort of the COO of Microsoft Research. I keep the trains running and make sure all of our really freaking smart researchers get to do fantastic research and don't have to spend their time dealing with bureaucracy and all that other stuff. I'm the guy that makes the bureaucracy go away. So
and where are we today?
We are in Building 99, which is the new home of Microsoft Research. We moved in the middle of November, and we're here in the middle of February now. I've been here about 3 months now and kind of settled in the building a little bit, but we love it. It's a great example of Microsoft's new initiative to just make our buildings a great fun place to be, to work in, to hang out and socialize with other people. So, and
this has been a work under progress for 2 or 3 years now, right?
Yeah, we started this almost 2 years ago. We worked with architects and with real estate and facilities here at Microsoft for about 18 months, and this is really the first new building in the whole new Workplace Advantage. They call it Workplace Advantage Initiative in Microsoft to make cool new buildings for us to work in. So.
And this was designed in part with the researchers themselves, right?
That's right. We had a committee of researchers who worked with the architects and facilities to have conversations about, what do we really want, our space to be, and what's important to the way we work that we should really incorporate in it. So, having a big, open space where you can see other people and serendipitously run into other people and sit down and have conversations and really, interact and collaborate, spontaneously instead of always like booking a meeting room and, ahead of time to go running off and sitting in a meeting room, or having individuals just sort of camping out in their offices and sending email. We really wanted a place that kind of drew people together to interact face to face and just have great conversations. And we're super happy because we really got that out of this building.
So who are you?
I'm Martha Clarkson. I'm the Workplace Design Manager for Microsoft, and I worked on this building at the inception and the changes that we've had to Workplace.
Come on over here and get away from the light.
We went through a whole workplace process with research. We spent about 2 years doing surveys and doing focus groups and senior management interviews. And then we went into a pilot phase. So we found some clients who already understood the value of workspace to support their business. And we got them on board and went through the whole process of how do you work, what will support your business, not what do you want, but how do you work? And so we came up with solutions for each of those to learn from it. And they were all very different.
Can you give me a sense of maybe 3 innovations that are in this building that you haven't seen in other workplaces?
Well, these kind of areas, the collaboration zone being dedicated down the center of both of the wings is really innovative for Microsoft. And we have had these glass panels here that you can see that they're writing all over, which is just like whiteboard, but lets light through. Daylight's a big thing for the people to have access to. So.
Especially here in Seattle where you don't get a lot of... Actually, we have good daylight today. What are some others? Some other things. That's one thing.
They had these demountable partitions that make up their office design are all movable. So if they want to take out a wall between them and collaborate, say work together for the duration of a project, they can do that. We'll store the wall. We'll bring it back. It's not going in the landfill. Their whiteboard and their tack board is embedded in it, so it's a system. But it has more light coming in, back to the daylight thing, which, yes, we need lots of coming in the top and coming in the fronts. So you can see each other, see who's in there. People not on the window can get more light.
Okay, that's number 2.
We have raised floor in this as well. So all the cabling, electrical, and the air is under the floor. They have controls in the floor that they can regulate the air with, and that's an innovative thing for See it a lot in Europe. Don't see it too much here. And first time for Microsoft to do a big, expansive design like this.
And a piece of that's cool for us is that, I mean, you see if you look at the floors, there are boxes. The raised floor is in tiles. So if you don't like where the air vent is in your office, you can move it somewhere else. They pop the tiles out and they move them. If you don't like where the net cable and the phone cable and the power is, they can move it. Wow. Right? It's all very, very modular.
It's about being flexible for the group.
So
now, tell me a little bit about the design. This is a different design than you usually see in a Microsoft building, which is usually just fabric or a wall of some kind. Tell me about some. Did you have artists come in and
we didn't have artists, although we have the art program. You'll see it through here, but there's really a push to use more texture and color and have more variety of spaces. So you'll see that, for instance, this whole row of collaboration area, and no space in here is the same. So it gives people a variety. Maybe I have a big group and we need this kind of a table. Maybe I have a more casual group and we need to be out there in the lounge furniture. So that's the idea, is give options for collaboration. Sometimes there's a high bar downstairs to sit stools. We're going to talk in a more public area. Maybe we need to come up here and whiteboard something. So that's a big innovation for us in this building.
How long have people been in the building so far?
3 months.
3 months.
Almost exactly 3 months.
Mm-hmm.
Yeah.
And what have been the experiences? What have people been saying?
I tell you what, so we have Jennifer Chase and Christian Borgs, who are the heads of our theory group and are the new managing director and assistant director of the MSR New England lab that we just announced last week. They're right over here. Why don't we bring them in the conversation? Because they're the users of this space.
Yeah. Hey, how are you doing? I'm Robert Scoville.
Hi.
Hi, I'm Christian.
Hey, so what do you two do here? And introduce who you are. Who are you?
Jennifer Chase. And
spell that?
Chase, C-H-A-Y-E-S, like Hayes with a C in front of it. And Jennifer, I spelled the normal way, not in any of the weird ways that some people do. So, and I've been here for over a decade, and I co-founded the theory group with Christian. But we are just moving now to Cambridge, Massachusetts, to open a new branch of Microsoft Research New England, which we're super excited about.
You just announced that a week ago or so.
We announced it a week ago, and it's the first branch of Microsoft Research on the East Coast. So, and it's just right next to the MIT campus. And we are really looking forward to working with people in the Cambridge area.
What do you think that, because each research center at Microsoft is known for something, right? I was in Cambridge, England, and they were known for their graphics work with the Xbox team. What's your center? Because you're running the center, right? What's the center?
Well, I'm the managing director, and Christian is the deputy managing director. But our relationship is much more nuanced than that. As we say, we're married to each other, we're principal collaborators, and we do everything together. So, so anyway, but I talk more, especially when I have a microphone near me. So I'll give you a little bit of the vision, and then Christian can give you more of the vision. But what we were thinking when we started this lab is that we believe that there is a new field that that's about to be born at the boundary of the hard sciences, mathematics, algorithms, very mathematical computer science, and the social sciences. Yeah. So we are very interested in talking to people who do sociology, who do psychology, who do economics, because we want to understand how people value things. That's why we want economists. Why people do what they do. That's why we want psychologists. Yeah. And sometimes we want to understand why people value things the way they do. So then we want behavioral economists. And we also want to understand how people interact with each other. Yeah. And then put that all together with the algorithms people to try to create online experiences that will help people to achieve what they want to achieve.
Yeah. When I was at the World Economic Forum a couple of weeks ago, I met some researchers from MIT who were building human-machine interfaces. In other words, trying to figure out how to take your signals from your human brain and turn that into a robot or a robotic limb to replace a limb that somebody had lost or something like that. Is that some stuff that you're going to think about? Are you going to get into the robotic world or the human?
No, not necessarily. We were actually more thinking of the online world, because we feel that in the online world, it's really very important that you don't just have people who do algorithms, right? Because, I mean, think about search and advertising there. Well, you need to do economics, right? And it's not anymore that you can have sort of an engineer who designs an algorithm and who doesn't worry about sort of business models and stuff, because he's supposed to design an algorithm which at the same time gets maybe in ad revenue. So suddenly in the online world, what used to be separate, you have your algorithms people there, and then you have your strategists and business people running here, and it's totally separated. That's not the case anymore in the online world. So research should do the same. We should sort of start to mix sort of the algorithms. How do you do things algorithmically, and why do you want to do them? What would it mean economically? We even feel you should throw in a little bit design, so that you don't only know how to do it and how do you do it technically, but also make it beautiful.
Yeah. And fun to interact with, right?
Right. Exactly.
You look at today's hottest products and they're fun to interact with.
Exactly.
And Facebook, you know, Mark Zuckerberg, I spent a little bit of time with, has a psychology degree along with a computer science degree. So I bet you're going to pattern some of your research right after what he's doing, right?
Right. We actually have done some little research on Facebook. We have been thinking how one can sort of model sort of the interactions you have on Facebook with all these different apps, and you sort of have a maybe even many party interactions. I mean, traditionally in auctions you have an auctioneer and you have sort of the person who wants to buy, and at Facebook it's sort of even more complicated. You have sort of somebody who runs a platform, you have the users, maybe you have some advertisement, so you get into this very complicated network of different entities who all interact with each other economically. So that gets you sort of as network, which is graph theory, which is sort of traditional mathematics, and economy, which is traditionally in the social sciences. Another example where you really, I mean, the words already says social networks. Again, social network.
Tell me about your background. How did you get here to Microsoft? You know,
How did I get here to Microsoft? Oh my path is a very windy path. My undergraduate degree was a biology degree. I thought I wanted to go to medical school, and then I realized that probably nobody would want to have me as a doctor. I wouldn't want to have me as a doctor because I'm always thinking about something else instead of, you know, what's right in front of me. I'm thinking way off in the future, which is great for a company like Microsoft, but it might not be great, you know, if I'm trying to like sew up your wound or something. And then I went to physics graduate school. And Nathan Myhrvold, who was the first CTO of Microsoft, was actually a classmate of mine at Princeton in graduate school. So he was doing quantum gravity, and I was a mathematical physicist. And then I went on and I did postdocs in math and in physics, and then I was a professor of mathematics for 10 years. And then Nathan convinced us to come here. And I thought he was crazy, of course, you know, and he said, oh, what you're doing is relevant for computer science. We were studying phase transitions, which is something from physics. Well, we were proving theorems, which is mathematics, that had to do
what
with...
are phase transitions?
Well, water freezing is a phase transition from one state to another state, and in combinatorial optimization problems, which sounds like a big word, but basically if you have resources and you have constraints, you want to try to use the resources to satisfy the constraints. If you have lots of resources, that's easy to do. That's an easy phase. If you have lots of constraints and very few resources, then that's a hard phase. It's an over-constrained phase. And as you pass from one phase to the other, you go through the most computationally difficult problems. And so we were studying that phase transition from the easy phase to the hard phase, from the under-constrained to the over-constrained problem. And Nathan said, wow, that's computer science. I was like, well, I don't think so. But anyway, Nathan convinced us to come here and start doing that. And actually, when we first met Bill Gates, I gave him a talk on this, and I told him that it was great that he was hiring people whose work wouldn't pay off for 100 years, which Nathan told me to shut up. But what's really interesting is about a year or two ago, so after about 10 years rather than 100 years, that line of research turned out to come up with some of the fastest known algorithms for solving combinatorial optimization problems. So, you know, things you care about like multicast problems. You want to multicast this, right? Okay, that is a constraint satisfaction problem. You have constraints you have to satisfy. You have to get this broadcast out to these various places, and you have certain resources, you have certain fibers, and you want to know how you're going to do that. And it turns out that some of the fastest algorithms for doing that came out of studying this bizarre phase transition and combinatorial optimization problems. So, yeah.
Other interesting things like that, when we started here, after a few months, we said, okay, we should do combinatorics. And people said, what's combinatorics good for? We said, well, combinatorics, sort of the math behind computer science. And people said, combinatorics, that's how you group sort of this into 5 groups and this into 3 groups. This is really boring stuff we learned in high school. We said, no, that's interesting. There are graphs and stuff. And they said, well, what is useful? We said, well, we don't know, but we should do it. Well, it turns out combinatorics is graph theory. Graphs are networks. And suddenly we are in the middle of sort of understanding how do you model the internet, how do you model social networks. So often actually you have no idea and you let people just do what they love to do. And suddenly, if you hire people in different areas who do what they love to do, then you make sure that if something new comes along, you have experts who actually can think about it in a structured way and have something reasonable to say.
Now tell me about tea. Research tea with the researchers, with the smart people.
Yeah.
So tea started in a building which is not as nice as this building. We moved to some other building at some point where there was an elevator. There were some concrete stairs in the back nobody used. So people took the elevator, everybody walked to their office, and we realized even our small group of 10 people plus some postdoc researchers, some visitors, so let's say 20 people, we don't talk to each other anymore. Everybody goes to their office. Yes, I talk to her anyhow. But otherwise, there were not many people talking to each other. We said, we have to get these guys together. And then we remembered, oh, when we were in academics, people had teas. So we decided to do teas. So every day at 3 o'clock, there's tea. It should be showing up over there soon. And people come there, they talk to each other. You give people free food, tea and a little bit of sweets, and they all come. And then they start discussing, and then they go to these glass walls, and maybe they disappear in their office and try to write something on the computer. But a lot of collaborations actually start at this daily tea.
Yeah. Well, and if you, last week I met the guy who invented the Nespresso machine over in Europe, and he's trying to build one for tea. So if you're really good, you can figure out how to make the best cup of tea and then go sell it to him.
Okay, well maybe that's something we can brainstorm about during our teas. You know, how to come up with the best tea machine.
Well, he had quite a talk on how he came up with the Nespresso machine, but and he's come up with tea, and he says it's all about the air oxygen mixture that you put into these drinking materials. Anyways, it's been a real pleasure,
It's been a pleasure.
I'm looking forward to coming out and seeing you guys in Boston
Absolutely.
and New Hampshire.
Come visit us.
And we're having the same architects help us to design our space out in Cambridge, Massachusetts, as the ones who designed the space here. And it's just really, really fun because we're brainstorming with them on how to do things like this that will encourage collaboration, that will encourage people to come out of their offices and start interacting. And I think that's especially important in our lab, where we're going to have such a huge spectrum of disciplines. So, I want the social scientists and the algorithms people to be sitting here drawing diagrams on the walls and starting to model it.
Very cool.
Well, thank you very much.
Thank you.
So we're walking around the second floor of Building 99 here, and you can see different people's offices here. And there's a lot of cool things we did in the offices. One of the things you don't notice right away, but because the floors are raised about 1.5 feet, and the ceilings are, of course, lowered. Actually, all the walls are modular, right? So if a group like this suddenly said, for the next 6 months, we want to have one big space instead of a whole bunch of individual offices, they could come in an afternoon and totally reconfigure the space. They don't have to tear out any drywall or build new drywall. They just pull the walls.
So
and
all these things
All
are
these-
totally modular?
they're totally
You
modular.
Pull them off?
Yep.
Is
all
it
the
very
walls.
expensive to pull it off? or-
No, it's really cheap. It was all all the materials and the construction was all designed so that they can pull it out and reconfigure it and reconnect it all very, very easily.
Tell me about the doors. 'Cause this is not a
Two things
typical
you'll see.
Microsoft
You'll
door.
see, glass, windows on the inside here and glass doors. A big part of that is really into natural daylight. Martha, mentioned that earlier. We really want to make sure we get as much natural daylight into the inside of the building as possible. So having a lot of glass really sort of enables that. We also wanted to make sure that we were, maximizing the efficient use of space in offices. So rather than have a door that opens in and that, of course, blocks a bunch of stuff and impedes a lot of space, having the glass doors on the outside like this and sliding pocket doors, it actually just gives you a whole bunch of space back. It really, it actually makes.
I can see that because in my office when I worked here, you would just lose a whole corner.
Yeah, now you have like real whiteboard space there and everything. You don't have stuck, anything stuck behind there. So
Now, if you had a researcher that was working on something really top secret, can they? Yeah, well, I guess this shows that you can black out.
yeah, if somebody, but actually, thinking about the overall usage of the space, we have moms here who are nursing, right? And so we've actually designed the space so there are mothers' rooms on various floors. That if that was important to somebody, they could, they could go to one of these rooms and really get privacy and take care of the parenting needs that they want to do. So we think about that. We think about things like somebody, because of their religion or personal philosophy, needs a place for quiet meditation. We have the kinds of places. We've allocated space in the building to do that. One of the issues for the theory group, because as we were designing out this building, we really tried hard to talk to all the different groups about their needs and what was going to be important to them. Folks in the theory group said, we have a ton of books, right? Books and having our books, in our offices so we can refer to them is important to us. Well, once again, we wanted to make sure that we're using sort of efficient use of space for people's offices. So one of the alternatives to having lots of bookcases in the individual offices we came up with was to put bookshelves out in the hallway. They're lockable, and there are different keys for the different sets of bookcases here. So maybe one or two people can share bookshelf space out here. It gets them out of their office. Actually, it's kind of cool, though. If you just sort of look down this whole thing, there are lots of scary titles on here of books that I would never in a million years understand, right? So it's kind of has a library feel to sort of look down here and see all these, the books. But we could accommodate people's needs to have a ton of books here and still, give them back a lot of space in their office.
Again, a more collaborative social.
It's a collaborative thing. It sort of unites the group in a sense. Here's another place where you just see we get tons of daylight, natural daylight in the space, and even kind of a gray, cloudy day, the building's really bright.
Yeah.
Right. It's very cool.
Is it fairly energy?
Yeah.
Energy efficient?
This is a LEED Silver certified building.
Okay.
Right. So that was something we designed in the building. We really wanted it to be energy efficient. Right. So we've applied for LEED Silver certification for this building.
Tell me about some of the other things that were built in for the energy efficiency. Do lights turn on automatically, or?
Yep, we have lights that we have various light sensors and timers on the lights as well, and they've really the materials that they used in the building and the heating and venting and air conditioning system, being able to, rather than sort of blast it for everybody, be able to give people much more individual controls over the airflow and the heating in their offices. Where they put thermostats, and they once again having the raised floors gave them much better ability to sort of pipe the HVAC throughout the building and have individual controls for individual people in it.
Now, here these are circular vents, but
Yeah, they're circular, and at the same time, you can see there's even controls on these for opening and closing them. All right.
very cool.
So but once it's hard to tell here with the carpet. Actually, you can see a little bit better on that set of carpet, but the carpet is in tiles, right? And the tiles are right above the underneath tiles from the raised floor. So if there's something they need to get out there, they lift up one tile of the carpet, they unscrew and take out one tile of the floor, do whatever they need to do, and then just quickly put them back.
very cool.
Right? I mean, honestly, you can't tell. I mean, if you get really close up to the floor, you can tell that they're individual tiles of carpet. But, they've really thought hard about the design of this building
Very
to make
cool.
that sort of thing work for it.
And in the offices, you said if you don't like the place that your vent is located, you can pull the tile out and move it over?
Well, yeah, individual. I can't do that in my own office, but we can bring people in, and it's cheap. It's not like they're digging up the floor and relaying cement or carpet or anything like that. It's just very easy to make that kind of change. One of the things we said, we worked for 18 months before we moved in this building with the architects and real estate and facilities and Martha's folks at how to build out this building to be a really good building for Microsoft Research. And we started with some of the basics, which is we're an open collaborative organization, right? We want to have serendipitous conversations. We want to, just sort of grab somebody and start having a conversation. We want to bring a lot of outside people in as well and have them be part of the conversation and collaborate with us, right? And that means, we want to have a building that really enables a lot of social conversation. We want to see people all the time, right? So
This is one of the first Microsoft buildings that I've been to that has a really nice atrium, an open, like a hotel atrium.
it's beautiful, and they worked super hard to design, and you can see sort of the big part of it's open, lots of natural daylight, and even on a gray cloudy day like this, it's super bright. It's just great to be in here. But, we can look up and see people on the fourth floor. We have this great grand staircase, so, I run into people on the staircase all the time. Just having this here, there are back fire escape staircases that are open and I could use them. I never use them, right? Whenever I want to go between floors, I always come here and go up and down the staircase because it just draws people to it. It's just so nice being here. We have a coffee bar down here in the atrium itself with tables, and I'll tell you, I come down here for basically the first hour pretty much every day with my laptop. We have wireless network down here. I mean, you can see people down here, working on the laptops and whatnot. And I'll just hang there for an hour. And because of the way the garage is right across the street from the main entrance to the building, everybody comes in through the main entrance. So I run into people every single morning and I just have great conversations for the first hour of my day, catching up with people just by sitting down in the coffee bar every morning, right? It's just, you can see, it's just this natural place that it's a magnet that draws people in, and we just have great conversations here, right?
Tell me about the design process at this building. Did you guys have 3D models to look at before the building got built, or did they have a design committee that showed things around?
We had a design committee of Microsoft Research people that was sort of representative of the different kinds of groups in the building that worked with the architects and worked with real estate facilities from early on to talk about what our requirements are, our dream wish list of things we'd love to have in the building. And we didn't get everything, but we got a lot of them. I mean, I'm just thrilled with the number of them that we got. Things like, if we got an atrium like this, it'd be a great place to have all hands meetings, right? And so it's kind of subtle, it's hard to see, but behind this big gray thing between the second and third floor conference rooms is a big projection screen that drops down. And if you look over on this side here, we have a high intensity data projector, right? Wow. We've got speakers and an AV system built in, so we can actually do all hands meetings. In fact, we've done a couple talks. We had Muhammad Yunus, the Nobel Prize microfinance guy, come and give a talk as part of our visiting speaker series.
Did he give about this room?
We made a little stage down there, and he actually gave us talk right down there. And we set out chairs out here, and it was awesome, right? We've done a couple.
Are you going to do weddings here? I can.
Actually, I tell you, one of the things that we really want to do is we want to do movie nights in here.
Yeah. Super Bowl.
Actually, we think it'd be great, particularly in the winter, a great Friday night family thing, right? bring in your kids, have them bring in their sleeping bags. They just kind of spread out down here, and we'll do a movie night. Fire up the popcorn machine. We just think I mean, how can you not do something like that in a space like this?
Oh, that'd be fun.
It's just totally cool.
People would come from around. I'd come from around the world. I mean, O'Reilly does Food Camp, and Yossi Vardi does Kindernet in Israel.
Yeah.
Why not movie night at Microsoft Research?
Absolutely, it's just totally cool. So
people could show their own movies too. Yeah. Are we done?
Oh, movies, yes.
What's this? Ruining the books
Book.
since 1990.
So we have the big doors right here. This is what's called an anechoic chamber. Okay. When you're doing our signal processing research group looks at cameras and microphones and speakers and all kinds of different kinds of signals you might get. Audio signals, video signals, images. We figure out how to compress them, we figure out how to transmit them efficiently, and whether it's tiles like we just saw in Worldwide Telescope or other sorts of things. But when we get into things like audio, we want to try different microphones, we want to try different kinds of digital compression and capture techniques for them. We want to try different kinds of speakers, analog and digital speakers. We want to do things like algorithms for locating sounds. So if you have an array of microphones and you're getting signals from a bunch of different places, can we actually triangulate the location of individual sources so we can do sort of removing background noise and echoes and things like that?
Well, this is going to be real important for like automobile microphones.
For stadium sound systems, or even just your own house, the stereo system in your own house. So when we calibrate those kinds of systems or test them, sometimes we need really good audio isolation. Yeah. So we have a room here. An anechoic chamber is a chamber where there's no echo. Yeah. The room is designed to...
It probably has a lot of foam and a lot of baffling on the wall.
Let's open it up.
Wow.
Oh, no way. Look at that. And that really...
Sorry, I interrupted your entrance, the grand entrance.
Where's the light switch? Right here.
So you have the quietest room in Microsoft, right?
That's right, and you have to go into experience.
Okay, so you guys got to go in.
Okay. Yeah, you really don't realize how much ambient noise is in your world until you come into a room like this, do you?
Can you start hearing your own your blood going in your ears?
Yeah. I feel like I'm half deaf or something. Sound deadening like that around me is just, you don't do that.
Well, this is what we need for our TV studio, right? So tell me a little bit about this room. What makes it so good at taking away all sound?
Well, it absorbs all sound down to about 140 hertz, which is most speaking range and above, and that's because of the shape of these. It's also built as a room within a room, so that it's isolated physically from the outside. It's built on solid ground on Earth.
Just that opening of that door, just the difference that made. It's fantastic.
It's got 4 inches of neoprene foam. Built on top of that is a concrete slab. Walls on top of that, ceiling on top of that, and it's all physically isolated.
How many rooms are like this in the world?
I have no idea. I know there's one other in Microsoft.
It's not as cool though.
I came from Bell Labs some years ago. There was a room or two there, but they're far and few between.
This probably costs $1 million to build a room like this, doesn't it?
I don't ask.
You don't ask. It's Bill Gates' money, right?
No, we're super careful. We're super careful about how we spend money, right?
No, but it's an investment to build a room like this.
It's an investment, right? It's an investment to have a research division, right? We are not a P&L, right? We're an expense for the company, and we're a bet for Microsoft that investing in the long term in research and technology is going to benefit all of our products. It's going to benefit the long term and the future of the company, right? Something like this, making sure we can do really great signal processing research is part of that bet, right? And it's important to the company.
Yeah. So what kind of work are you doing in this room?
So we use the room to study speakers and microphones, and those eventually become the mouthpieces and ears of a computer. So when you talk to and listen to a computer, we have to study how the signal gets in and out of that computer. So we'll set up a microphone, for example, over here in this room, and study how what its sensitivity pattern is in terms of frequency and different directions. So we can put that microphone in, say, an automobile or in a conference room box and do better teleconferencing or talking to your computer in an automobile, something like that.
Very cool. So we're standing on a mesh floor. This is an interesting floor.
Yeah, it's made out of airplane wire, and it's just so that you don't step on the mesh, the wedges underneath, because they're all around.
Wedges made from? What are the wedges made from?
Styrofoam.
Styrofoam.
Yeah.
Is there a significance to their exact shape? Because they all seem to be the same.
Yeah, the significance is that they're trying to capture all the different wavelengths of both. This is a quarter of a wavelength of the longest wave that's being absorbed, and then it goes all the way down to the highest wavelength.
So the waves go in and they don't come out.
Yeah. Roach Motel.
Wow. How did you get into this? What's your background? What got you
Signal
into
processing? Yeah. We studied the Texas Instruments Speak and Spell back as an undergraduate, and that's how we got into signal processing.
What gets you up in the morning? What's interesting about your field?
Well, these days I'm really interested in the teleconferencing and telepresence, immersive interaction between people, and how computers can mediate between that.
Interesting. And the research team came out with the ring cam, right? Which was, is that based on some of your work?
Yeah, that's this room, or the room that was corresponding to it in the old building, is critical to that product.
And tell me how that works. What does that do that previous products didn't do?
Well, it has a microphone array.
This is the round table. The round. It's actually launched as a product now called the round table.
Yep.
Thanks for clarifying that.
Yeah, see, I haven't worked here for a year and a half, so back when I worked here it was ring cam or something like that.
It was
the code
ring
name
cam
when we were building it, and now we actually shipped it and we call it round table.
Round
and people
table.
can go out there and buy it.
Yep. So tell me what it does that other products didn't do.
So it's got audio and video connected together, and it uses a microphone array in a ring to track who in a conference room is speaking, and it will direct the video to go and look at that person, so that a person in a remote room can understand who's talking when in that conference room and get a good audio experience as well as the visual.
Right. What other kinds of uses are you seeing now for array kinds of microphones? The first time I ever saw an array microphone was in a car, where somebody had put 4 microphones in his visor, and the microphones could filter out noise and could tell who was speaking a little bit like that. But that was 2 years ago,
Right.
3 years ago, so I'm sure that lots happened in array microphones. So.
Well, it's the same thing on a computer that you might carry around with you. If you notice on your laptop, you might have a two mic array, and it's built into Vista. We're thinking now of ad hoc mic arrays, so when people go into a room with multiple laptops, how do they all work together as one humongous mic array, and will help conferencing even without infrastructure that you might otherwise have.
Now, using your techniques, you could remove noise from like my video, because when we go back out, you'll hear the fans in the room and you'll hear the ambient noise. If you actually if you had a computer and the camera picking up, several microphones, you could actually remove noise live, couldn't you?
Right. So we remove noise. We can also remove other speakers. But you don't want me in the thing. You can edit me out. You don't want to be confused by things that are coming out of speakers. So we with mic arrays you can remove all that.
Yeah. And are you starting to, the Holy Grail, I guess Bill Gates gets asked every year, when's real speech recognition coming? When is it going to be like Star Trek, that we can just talk to a wall and a computer does something? Is that getting closer because of these array microphones?
Yes, actually in the Ford Sync product, we're actually using mic arrays and doing speech recognition in a real environment.
And that's here just in the last year, right?
Yes.
So
we should probably move on.
Well, thank you.
We're a software company. We're, the vast majority of what we do is software research, but, devices, whether they're embedded in the walls and ceilings and desks, or whether they're mobile things that we carry around, are changing so fast, and the underlying components we build on are changing so fast that you really got to ask the question: what kind of software do you need to build for those, and what kind of software is interesting or potentially cool to build for those. So we've got a little hardware group that we use to sort of prototype up some ideas, and they work very closely with all our different software groups, whether it's like adaptive systems and machine learning, to figure out what kind of algorithms we can build into the those devices so that they sort of understand what we're doing and adapt more to us, or networking. And here's a great example of kind of hardware device. This actually isn't a research device, but it's kind of thing where sometimes it's like you grab people and you just want to find a conference room to sit down, right? And it's like you can walk up and say, well, okay, is it going to be free, and how long is it going to be free? Just having this kind of information, dynamic, this is dynamic in real time, just right there, so you can immediately go boom. And oh, this one's free. And if I just grab somebody and I want to use it right now, I just say, okay, reserve now for the next hour. Okay, done. Now it's mine for the next hour. Right? That's all I got to do right there. And now anybody else sitting at their desk who wants to book a room can now see that that room is now reserved for the next hour.
That's very cool.
So, I just have to mention this. One of the things we said when we were designing the building was, we wanted to be social. We expect people to run into other people on the staircase, right? Put something at the top of every flight of the stairs so that people run into each other, they can just sit down right there and talk, right? So, right at the top of the stairs here, we have a place where they can just sit down and talk.
Yeah. Tell me a little bit about the art program, because that's some famous Microsoft thing.
Yeah. So I'm not a huge expert on it. I mean, I know a little bit about it just because I've been at the company for a long time. But Microsoft has a fairly extensive art collection, and they, in fact, have an art curator whose job is to build the art collection. They have a whole sort of specialty around Pacific Northwest art and Pacific Northwest artists, which helps the local economy as well as represents, that's kind of, I think at one level, the kind of art you want to have in Pacific Northwest buildings, right? And you look at sort of the wood and stylings used for the building. That I think this is the kind of build they thought about, how do we make this fit in the Pacific Northwest as well. So I think sort of there's a good aspect of that as well. It's representing the local art community as well. We actually have right in the sort of wall here, and hopefully we'll be able to go in and see it in a sec. We have a room that is set up like a conference room.
Yeah.
With one-way glass. So we can actually run lab experiments with...
Stop here for a second so you can get some good video here.
Well, we're going to go in here in just a sec. There's Andy. Andy's too. We can run lab experiments with
Rocky wants one.
We can run lab experiments with a bunch of people sitting in a conference room and see how they use technology in a meeting. We have a living room kind of setup, so you can bring a family in and see how they interact with interactive equipment. We have sort of set a cube or a bigger office room with a bunch of tables. So if a bunch of people are all trying to work together, we can run those kinds of things too. So we're really trying to sort of mix up the lab space a little bit more so we can run different kinds of experiments.
I'm Robert Scoble.
Nice to meet you. Herbert Banco.
Banco? Yeah. I'm Kevin. Nice to meet you. This is, of course, Andy Wilson.
Hey, Andy again.
Good to see
how
you.
you doing? Got a new office.
Yeah.
Did you hide all the cool stuff?
It's all in here. No, it's all in the open.
For people who don't know, Andy is you build the coolest stuff at Microsoft, I think. You were at Maker Faire last year and showing off different interfaces for using cameras, and you've done lots of Bill Gates keynotes and lots of fun stuff, right?
Yeah.
So what are you working on lately?
Well, we're right now getting ready for Tech Fest, which is our big event.
So how are you going to blow everybody away? Because that's the goal, right?
I'm not ready to tell you everything yet. We're still working on it. We're working furiously right now, trying to put everything.
Now, do you have a prayer of getting everybody's attention when you're next to Curtis Wong's new worldwide telescope?
Well, we'll see. A
little competition in the lab, huh?
That's good. We'll have something fun. Yeah, it'll be good.
You're famous for doing some of the multi-touch stuff, right? That's public stuff, right?
Mm-hmm.
The table computer. What do they call that thing? now?
Surface.
Surface computer. Sorry. Is this one?
It's not on at the moment, but
Okay.
yeah. And here's a earlier prototype that we did, which I still use for some kinds of development.
Yeah. And so your specialty is trying to come up with interesting new interfaces between humans and machines, right?
Right.
So
Overall,
you're using cameras, like this machine has, what, five cameras in it underneath it?
This one doesn't, but yeah.
Okay.
Yeah.
But-
So the goal is to
look at different kinds of form factors and different ways of using sensors to make new user interactions. And that extends from the basic sensing technology as well as the interaction model and how it works. And I don't get too heavy into the applications. Other people are going to be doing that. So
Make a better camera image stabilizer.
Well, tell me a little bit about some of the stuff we're seeing in the lab. Are you allowed to talk about this sphere?
Well, so Benko is working on this device. This is basically a spherical version of Surface, if you will. So it's a fun device. We're playing around with different ways to different kinds of interactions and applications that make sense on spheres, and we'll be showing some of those at TechFest. This is a new unit. We're still getting this one working.
Very cool. Tell me a little bit about the Minority Report screen over here.
Well, so we're getting back to working on that. This is some stuff that we did a few years ago with the hollow screen material, and we're also looking at other kinds of. We're looking at interactions that really focus on surface. No, it's okay. So we're looking at interactions on the surface as well as above the surface with this particular display.
How much is this glass gotten cheaper since the last time I talked?
I don't know. I haven't
bought one of these in my house.
Yeah, I haven't bought one for a little while. I know there's more than one source for these kinds of things now, so that's always good.
So tell me about working in this new building. You just moved in 3 months ago. How is this new building helping you work?
Well, the biggest thing, right, is just having the lab space. I don't know. I mean, you saw my old
office. It was small.
It was cramped. I mean, it was I ran it like a ship, right? And we had a few spaces across the hallway, but now this is more of a cross-group area to do prototyping. For the moment, Benko and I are pretty much running wild in this space, and eventually we'll have more things going on. And next time you visit, hopefully there'll be more things happening in the space. But it's also.
I wish you just put a webcam in the corner so we could watch you work.
Yeah. So there's also a bunch of equipment and facilities for doing usability testing in the other rooms.
Is that part of this office?
Yeah.
So you can bring people in here and.
So I think there may actually be something going on, some tests right now in this room. But we can walk around to the other side and look at the control room. This space, we're just getting set up right now. This is more of our living room, more of a residential or consumer space.
Okay. So you can sit down here and really have some discussions of how things would work in a house or something.
Yeah, so we can bring in some of these technologies and actually maybe watch people use them, or also set up a really nice demonstration space, right? So we can. Keep a little bit of that off to the side so that things work when you come around for, these kinds of videos.
Now behind here is a two-way. This is a two-way glass or one-way glass.
So we have this is one-way glass, and then there's a control room over on the other side. And I believe I can't tell if somebody's in there right now. It's awfully difficult to look in there. There may be somebody in there. We can take a peek. It probably won't disturb them too much.
How did you get involved in this field? One doesn't just wake up one day and say, I'm going to build really cool computers with cameras.
Well, in graduate school, I studied computer vision and pattern recognition. And I was at the MIT Media Lab, and there the focus was how can we use those kinds of techniques, among many others, to make new interactive experiences. Yeah. We were always really into building new, cool user interfaces and displays and new ways of using computers. So I'm not there anymore, but I keep doing that kind of work. And so it was very natural for me to pick up on that when I left.
When I've talked to visionaries or people who are really trying to push the future, some of them get frustrated. Like I interviewed Doug Engelbart. And he was pretty frustrated with the state of research and the state of computing, the state of users, because it took 20 years for his mouse to get really used in a modern day product, right? Are you seeing the same kind of frustration where you're seeing a new world that could be one day and you're trying to get people to see that world along with you?
Well, I don't have any expectations that these technologies are going to be picked up overnight. I mean, I think the mouse is a great example where, we have to set our expectations appropriately. We're doing a lot of things now that I think will show up eventually in one way or another in the real user interfaces of the future. Yeah. It's hard to say which pieces will get picked up, and as we go forward, there'll be a winnowing process. We'll find the things that work and throw away the things that don't work and carry on.
That's really the reason you have this room behind you to test
Right.
your ideas and see how
Exactly.
real human beings use that technology.
That's right. Right. So we have all sorts of recording facilities, and of course everyone there is, knows they're being watched, and they sign off on this, so it's not a big deal. And so these are the kinds of standard suites that we have throughout campus to test some of these new ideas.
Yeah. Where do you think the next 2 or 3 years for you is going to be? What's the bleeding edge in your lab? What gets you going in the morning, I guess?
Oh, that's a really good question. Right now I'm just really focused on doing a couple key demos that we'll show at TechFest, and we'll see what happens from there. I mean, I'm still very much interested in interactive display technology, looking at the various interaction models, and thinking about different ways to relate to stuff that's on the Surface unit, different sizes of Surface units, and so forth. We'll see. There's a lot.
Cool. Well, thanks a lot, man.
Thanks.
And
Good to see you.
I guess I'll have to come back on the 4th to see.
Yeah.
You have an invitation?
Yeah, please do.
Thank you very
fun.
much. Thanks.
Good to see you.
Now, there's behind me is a public part of the building, right?
That's right. So we're in the reception area, haven't gone through security yet, and we said, we said it was really important to us to be able to host a lot of workshops with, people coming in from the outside, from, great schools all over the world, MIT, Harvard, University of Washington, Stanford, Berkeley, dozens, hundreds of different schools we have active collaborations with. We want to be able to have all those folks come here for workshops and symposia and lectures and other things like that. And we said, we don't want to have to escort them around past the security all the time. So can we build out some lecture space for us so that we can do that really, really easily? So,
So I'm allowed in here without a badge, right?
you have a badge. We're not going to shoot you for coming home. But
I used to have a real
we built
badge.
that, so we actually have 3 lecture rooms in here.
Yep.
We have a big one on this side, and we have 2 small ones on this side. We have sort of lounge space out here where people can sit down, an internet terminal where somebody needs to check their email can do that. But we really actually try to make this a self-enclosed space. We have a separate set of restrooms out here. We've got a coat rack area over here so that we can have people come in here. We have,
So if an employee wanted to throw a user group meeting or a little a presentation, they can rent the room?
Yeah, we wanted an evening user group meeting or something like that. We can totally do it in here. So this is our big lecture room. And, oh, cool, the door's open. We can go in the back. Hey, I'll show you in the back. So one of the things that we do in these rooms is not only do we record our presentations, but we netcast them. So people around the company can watch them without necessarily all having to come over here to see them, right? We have a very active netcasting.
And some of those are put in the public space as well.
Yeah, actually, we put as many of them as we possibly can. We partner right now with Research Channel of the University of Washington, so that we actually publish those both on the internet and on Internet 2 as well. So in the back here, we actually have 3 control rooms where we can actually, you can see a little thing. This is what you guys want, right? Yeah.
So you can see all the
So actually,
cameras from around
so look
the-
through here. So you have three of these control rooms. We can control any of the rooms from any of the booths back here. Right, it gives us a lot of freedom, and we can netcast from any of them.
And you got
out to the
robotic
corporate
cameras
mount.
too, right?
We got robotic cameras. They can control all the cameras from all the down places. And there's nothing going on here. So yeah, there's nothing going on. Here's one of the 2 small ones. Really, really cool, flexible space. There's more lounge space in the back. So, with actually.
So the MVPs will probably really be treated well here, huh?
But this is, this is a case of something that was really important to us. We said, this is important to the way we run Microsoft research, and we need space that'll really support this. And the company, the facilities folks, and the architects are really good about, working with us to build out a space here that was just going to really work well for our needs. So.
Well, this really rocks. So thanks for that great tour.
Well, thanks for coming
This
out.
was really
Appreciate
a great honor for me.
It's good to see you again. You're
So-
going to have to come back and we'll show you more cool research that we're doing here. God knows we got enough stuff going on. And hopefully you can come back for
to see what Andy Wilson's working on
hopefully
for TechFest.
Hopefully you come back for TechFest.
I'll try.
Okay.
Anything else we should know about this building? It's a pretty cool building.
Yeah, we're loving it. It's cool.
Well, thanks so much for giving me a tour.
Thank you.
And we'll see you soon again.
Yeah.
Thanks.
Thanks.
Bye.